For assignment 2, we need to identify engineering related problem and design an application to solve the problem. We need to apply programming concepts such as decision and repetition structure, array and vector concept, and text file processing. So this is the question that my group has produced, where a residential heat pump is used to provide heating during the winter season to maintain a house temperature at 21 degrees Celsius. The heat pump has a COP of 3.7. The text file below shows the day, the average temperature outside of the house, and also the heat transfer into the house daily for a week in megajoule per hour. Write a C++ program that will prompt data from the text file the temperature during winter.txt and display output of the analysis. The C++ program will perform analysis based on the table below. The C++ program will contain 4 different functions. The first function is to calculate the actual power required by the heat pump. The second function is to calculate the average and the highest amount of power used by the heat pump. The third function is to calculate the minimum power required. This is when the heat pump is replaced with a Carnot heat pump, which operates at maximum efficiency. Hence, calculate the power required for the Carnot heat pump. The fourth function is to calculate the electric bill for the week. The heat pump is assumed to operate 24 hours every day. So calculate the unit of electricity used and the bill of electricity based on the rate below, which is the first 15,000 unit, we rate 1.5 ringgit per unit, and the next unit until 45,000 unit is 2 ringgit per unit, and more than 45,000 unit is 2.5 ringgit per unit. So the question is related to a thermodynamic concept, which is based on the second law of thermodynamics. The formula to calculate power is COP equal to Q divided by W. So after derivation, to calculate the power, we will need to divide the heat into the system Q divided by COP. And then for the third function, which is to calculate the minimum power, first we need to calculate the Carnot COP, which is Carnot COP equal to temperature in divided by temperature in minus temperature out. Then after we get the Carnot COP, we will need to calculate the minimum power, which is equal to heat into the system Q divided by Carnot COP. For the flowchart, this is the flowchart for the entire system, entire program. So this is the main flowchart and this is for sub flowchart related in this program. So in the first main flowchart, we will start the program and I will declare integer option I, temperature in, highest day, declare float, highest equal to 0, and I will declare a few vector, which is day, temperature out, heat transfer, and power. And then we will read day, temperature out, and heat transfer from the text file, and then we will prompt and get option from the user. So we will have a loop here which will continue until user enter option as equal to 0. Only then the program will end. So if the user enter option equal to 1, we will proceed with the first sub function, which is to calculate power. If the user enter option 2, we will proceed with calculate average and highest power. If the user enter if option equal to 3, we will proceed with calculate minimum power. If user enter 4, we will calculate electric bill, and then we will prompt and get option from the user until user enter 0 to end the program. So this is the flowchart for the first sub function, which is to calculate the power. So we will have a loop here where we will calculate the power using formula power equal to heat transfer divided by COP, which is 3.7, and then we will display the power, and then we will add the value of I until I equal to 7, then the program will end. So for the second sub function is to calculate average and highest power. So first we will have a loop which will calculate the power and sum the whole power, and then we will do a selection. If power is larger than highest, then highest is equal to power and highest day is equal to I plus 1, because I started from 0 and they started from 1, so we need to add the value by 1. And if the power is not equal to highest, no, we will just add the value of I, and the loop will continue until I becomes 7. And then after the loop has ended, we will calculate the average power is equal to sum divided by 7. And then we will display average power, highest and highest day. So for the third subfunction, which is to calculate minimum power, so we will do a loop for I equal to 0, I less than 7. First we will calculate Carnot COP, which is equal to temperature in divided by temperature in minus temperature out, and then we will calculate the minimum power is equal to heat transfer divided by Carnot COP, and we will display the minimum power, and then we will add the value for I until I reach 7 and the loop will end. So for the fourth subfunction is to calculate electric bill. So to calculate electric bill, first we will do a loop to calculate the power, which is equal to heat transfer divided by 3.7, and then we will calculate sum of electricity use. So electricity is power times with time, which is 24 hours. So power will times with 24 hours, and then we will sum all of the value. Then I will be added, I plus plus, until I reach 7 and the loop will end. Next, we will divide sum with 3.6 because we want to change sum from kilowatt hour to unit of electricity. And then we will evaluate if selection. If unit is less than or equal to 15,000, we will use this formula. If unit is less than or equal to 45,000, we will calculate amount using this formula. And if unit is more than 45,000, we will calculate using this formula, and then we will display the amount, and then end of program. So that's all for the flowchart. Thank you.
Hello, I'm Aiman, and I'm going to explain the first half about our code. So the first we include all the functions that we want to use in this code. Then we declare the integer variables that we wanted to use. So as for example, integer option and I, character option 2, and a constant, that is integer temperature in, that is 21. So then we declare the vectors where we wanted to use. Vector in the bracket integer, then the variable, that is day, and 7 spaces in the vector. Then a vector that is float type, temp out 7, temp heat transfer 7, and also power 7 spaces. Then we use this if stream in file. We declare the file and we open the file in drive D named temperature during winter. So this is the file. So you can see user already input the data in the text file in drive D. So day 1 is -4 and 75. So the way we use from the file to we use the file and we insert the data into a vector. We enter a loop for I equals to 0, I less than 7, I plus plus, because we are only 7 days. So 0, 1, 2, 3, 4, 5, 6, 7. So we enter the program will enter the data into the vector using in file, day, temp up, and heat transfer, and the program will enter a loop until all the data, all the 7 data is entered into this vector. This is to check or to display the vectors that the program has input from the text file, whether it is functioning or not. So if you want to look at if the program had entered the data from the text file, so yeah, it is from the text file, and the output here is the same. So the program has entered the data from the text file into the vector in this code. Next, we enter a loop, do while loop, to start the program that we wanted to use. So we display to the user, welcome to the heat pump analysis menu, please enter option. User can enter any option they want. The first option is option 1, to calculate the actual power at COP 3.7. Then option 2 is to calculate the average and the highest amount of power used. Option 3 is a minimum power at maximum efficiency. Option 4 is an electrical bill for the day, and if the user enters 0, the program will exit. Then the program will ask the user to select which option they want, and the user will select, for example, option 1. User type in option 1. Then we go to the decision, that is, we use a switch case, the case of option. So if the user type in 1, it will go to case 1. It will go to this option. This will display the actual power at COP 3.7. So the program will enter the loop for the vector and will calculate the power for each day. So for I equals 0, I less than 7, I plus plus. For power 0, that is day 1, equals to heat transfer 0 over 3.7, that is the formula. So then the program will output the power at day 0 plus 1, that is day 1, equals to, we set the decimal point to 2, and the program will display the power in megajoule per hour. Then the program will ask the user if they want to go back to the main menu or exit the program. Then the user will enter Y or N. So if the user enter Y, the program will re-loop to the starting of the loop. But if the user enter N, the program will exit. And the program will display, program will now exit, thank you, and in file close. Same goes to option 2. If the user enter 2 at this option, it will calculate the average and highest amount of power used. Then the program will enter the decision number 2 here. In case 2, first we declare a float, sum equals 0 and average equals 0. Then we enter the loop for the vectors that we wanted to use. Sum plus equals to power I. So every day 1, 2, 3, 4, 5, 6, 7 will be used, and we calculate the average equals to sum over 7 because of 7 days. Then we also declare the variable float, highest equals to power 0 and highest day equals to 0. So this will calculate the highest amount of power that is used. So if the first day is lower than the second day, then the second day will be the highest. The power for the second day will be the highest, and the highest day will increase from 1 to 2. Then the program will check again if the second day is higher than the third day. If yes, then it will not enter this decision. It will skip. The program will check if the fourth day is higher than the second day. If the fourth day is higher than the second day, the program will enter this decision. If highest equals to lower than power at the day 4, then the day 4 is equal to the highest. Then the highest day will become day 4. And so on until day 7. Then the program will display the average power use is the average that we already calculated, megajoule per hour. Then the highest amount of power use is the highest, megajoule per hour during the day. What day is the highest? Then same as case number 1, the program will ask if the user want to go back to the main menu and do the calculation again, or exit the program. If the user enter Y, then it will go back to the main menu. Then if the user enter N, it will exit the program. And of course, if we want to use a case of, we need a break at the end of each option. So it's case of 1, we need a break here, and case of 2, we need a break here.
Assalamualaikum. So I will be talking about our coding program in function 3. So in function 3, we calculate the minimum power required for the Carnot heat pump. So first thing first, we declare variable Carnot code mean power and temperature in, which is 21. So we do for loop. Initially I equal to 0. When the condition is I less than 7, they will perform this calculation, and then they will print the output, which is the day and the minimum power, and the loop will run until the condition is I equal to 7. After the loop end, then the loop will end. After the loop end, there will be a decision to make where the user can back to the main menu or close the program. So let's talk about function number 4, which is electric bill for the week. So in this question, we need to calculate the unit of electricity used and as well the bill of electricity based on the 3 conditions below. So first thing first, we declare variable sum, amount and unit, and then we do perform for do loop, which initially I equal to 0, and since I less than 7, we will sum up all of the power and times 24 to calculate it well. Then this loop will go until I equal to 7. Then we will count the unit by using this formula. Then there are 3 statements that we take from the question, which is the first thing, if unit is equal or less than 15,000, the formula are as below. And if unit are less than or equal to 45,000, the unit are the formula are as below. And the last thing, if the unit is more than 45,000, they will perform this formula. Then the last thing, they will print out the output, which is the total bill for 1 week. Thank you.
Hello, this is the sample of the running of the program. There are 2 samples. For the first sample, the user choose option 1 and it will choose power at CLP 3.7 for the whole week. And then the program asks again whether they want to go back to the main menu, and the user said yes. And the user also selected option 2 for the next one. And this will show average and highest amount of power used. And then the program also asks again whether they want back to the main menu, and the user said yes. And the user choose option 4, and this will show the electrical bill of the day. And the program asks again the user whether they want back to go to the menu, but they say no, and then the program will exit. For sample number 2, the user selected option 4, and this will show the electrical bill for the day for 1 week. And then the user choose they want to go back to the menu, and they choose option 3 for the next option. And this will show the power at maximum efficiency for the whole week. And then the program asks again the user whether they want to go to back to the menu, and they say yes, and they want to go back to the menu. But at the menu, they choose option 0, where they will exit the program now. And that's all for the sample.